So let's remember, we want a standard normal distribution because then we can allow certain characteristics to happen. We can force the area to be equal to 1. We can force the mean to be equal to 0 and the standard deviation to be equal to 1. And we do that all with a z-score, which is x minus mu divided by standard deviation. That was the big conclusion of Monday. Now, why do we do that? Why do we bother forcing the area to be equal to 1? Yeah. Why do we bother with all this?
1 is the whole, right? The whole.
1 in the whole sounds like a golf term.
1 is like the whole picture that you're looking at. Everything is just a percentage out of it.
Good. I need more. If we make area equal to 1, we can equate area to probability. And if we can equate area to probability, we can deal with this based on the area and draw conclusions about probability with it. Okay, let's look at an example. Let's say we have a factory that produces thermometers. I'm talking, the good old mercury-containing thermometers. You stick it in stuff and the mercury moves up and down. And let's say that this factory has measured a mean of 0 and a standard deviation of 1. Let's say that this factory has measured the mean of 0 and a standard deviation of 1.
1 degree?
Yeah. And let's make it Celsius, just so it's fun. And the readings were normally distributed. It's very, very unusual to get a normal distribution with a mean of 0 and a standard deviation of 1. But let's say we had that. That's out. Now, how do we test thermometers? We take a bunch of thermometers, we stick it into a solution that is at 0 degrees Celsius, and then we measure what each thermometer is showing. So they could show 0, but they could show something else. If we average all of those temperatures that they are showing, we still get 0, which is good, but we get a standard deviation of 1, which means that not all of them are at 0. Well, 1 standard deviation, so most of them will be within 2 degrees of, right? And now we are looking at find probability that a thermometer probably selected at random, but thermometer will have a reading of less than 1.58 degrees Celsius. Right, so we have the batch of the thermometers. We measured all the thermometers at the company. We're going to pull one out of the bunch. We're going to stick it in a solution of 0 degrees and look at the temperature. And we want to make sure, we want to know what the probability is of finding a thermometer like this by random.
Is that a question?
Yeah, it says here, find. doesn't say teacher tell them, it says find. It's a challenge. It's a quest. There's experience and loot to be have. Experience points and loot.
Outside is not standard deviation.
I'm asking about less than. Okay. We dealt with this before, and we like to have some understanding of how to do it. So let's look at the steps. How would we get there? Well, we talked to step one is we don't know if this is standard normal. Even though it behaves like a standard normal, we don't know if it's a standard normal distribution. So we have to make it behave like a standard normal. And we get that by finding the z-score. So step one is find the z-score. Once we have the z-score, what is the z-score? Oh, the z-score is 1.58 minus 0 divided by 1. So the z-score comes out to be 158. Very lucky for us. Unusually lucky. Okay. So step one is find the z-score. Once we have the z-score, right, we have a standardized step two. And this is non-negotiable. And I mean non-negotiable. So the non-negotiable thing about this class, and this chapter specifically, is step two, you draw the goddamn picture. And I mean goddamn picture. Why? Because only 10% of my students that don't draw the pictures pass this class. 10%. Everybody who thinks that they can do this, all of this in their head, eventually fails. So we're going to draw the picture. And this is non-negotiable. When we're talking about z-scores, a picture is a must. And if you look at my exams on Wednesday, you will see that, well, not in this exam, but on my final, there will be definitely a thing in bold, large font saying goddamn picture. Because the picture, if you don't draw the picture, the chances of getting the question right just go out the window. And I've been burned enough times trying to convey this message. So I resort to the one message that works, humor. Okay, so let's draw the picture. What is the picture? Well, the picture is the beautiful, symmetric, bell-shaped curve. Okay. What's in the middle? Well, in the middle is the mean, 0. Why is it 0? It's not 0 because of this 0. It's 0 because we just made it standard normal. Using the z-score, we just turned it into standard normal. And then where's 1.58? 1.58 is to the right. Now where you're going to put it, that's up to you. As long as it's to the right side, I'm okay with it. Leave yourself some space for drawing. And which area are we interested in? Right? Again, we are talking about probabilities, which means we are talking about area. Which area are you interested in? To the left or to the right?
Oh, to the left. To the left side.
Well, my right, your right, right?
Yeah, that's right.
We're interested in less than. Right?
So inside.
Everything is up
underneath that.
So we're interested in this. Mind you, this goes to negative infinity one way and to positive infinity the other way. So we're interested in this. Okay, and then step 3, we find the area. Which is probability. Please tell me you brought one. Yes. I was like, I don't have any extra. All right.
Said more than 1.58 would be right.
Then we would cover this one. Okay. Page 2 of your handout has one table, and then if you look at on the other side, there's another table. So there's two tables. Those are called standard normal cumulative probability tables, or z-score tables. Everybody got one? Okay. Those tables have 4 features. Feature number 1, on the very top in the right-hand corner, there's a picture. It will help you, just in case you get confused, stressed, anxiety, there's a picture. So that's feature number 1. Feature number 2 of this table gives you the probability assigned to a z-score to the left of that z-score. All of those probabilities, all those areas, talk about the area from negative infinity to your z-score. And that's very important to remember. Again, if you forgot, look at feature number 1, which is the picture. It tells you. Feature number 3, it provides you a way to read a z-score. If you look at the left very much column, it says z, and it has 2-digit number. The third digit, or the second decimal places, can be read on top. So if you are looking for 1.58, we're looking for 1.5 here, and then 8 on top.
Would be 1.6. Should we use 1.6?
No, we're looking for,
1.58.
yes, 1.5 here, and then 0.08 here. So if you go, right, it's a 2-dimensional table.
So that's the probability, 94%.
That's a probability to find, that's a probability or area assigned to the left of z-score 1.58. So in our case, yes, that's the probability of this. So what do we get? 0.9429 or something? That's this area. Okay. So again, the area is to the left of the z-score, negative infinity to the z-score. The z-score is split up. First 2 digits on the vertical, last digit on the horizontal. And then the meaty part right here is the probability. If you look at 0, 0, it says 0.5, which will make sense. 0, 0 is right in the middle. So the probability of half of it is 50%. It makes sense, yes? Anything above should have a probability higher than 50%, and anything below should have a smaller. Now, if you look at the very bottom, 3.49, what's the probability for 3.49? It's 0.998, right? For the most part, most textbooks don't consider z-scores above 3.5 to be worthy exploring because that's 99.99%. Right, as we did with the example on Monday where the z-score was negative 35 or something. Right, that's just not happening. Okay, so that's that. Let's try another one. Let's consider the same factory, and let's look at 2 more. So let's say we want greater than negative 1.23 degrees Celsius. And let's do this one. So same idea. We plug a thermometer out of a pack, and we want to know what is the probability we're going to pick something that in a 0 degrees Celsius solution reads more than negative 1.23 degrees.
So we already know the z-score. The z-score is still the same, right?
No, we calculate the z-score for that number now.
Oh.
But in this case, z-score should be relatively easy. It's negative 1.23, right, the x-score, minus 0 divided by 1. This is one of the only examples you can get that has this mean of 0 and standard deviation of 1. But we're doing this so it's easy to see where things are coming from. And again, step 2, we draw the picture.
This time it's going to be right.
Yes. So this time we're looking at greater than negative 1.23. So negative 1.23, and we're looking at this area. Here's the problem. Our table only provides us with the z-score and probability to the left. So the table will only give you this little fragment. So if you look up negative 1.23, you're going to get this space, not this.
Did you just subtract that from 1?
Yes. Right? We know that this plus this is equal to 1. Yes? Yes.
Oh, negative.
I put new batteries in my mic. We can hear you. We all
Oh,
can
you
hear.
divided. I thought it was a positive 1.23.
It's okay. Look, today I'm very forgiving because today we are learning. Monday I will start snickering because that's motivational. It's good teaching practice. So what's the probability for this area right here? So let's look at z-score negative 1.23. Negative 1.23. Right? Negative 1.2 and 3. And what do we come up with? Front row, got something for me? No? No?
0.109.
Right? So this area right here is this. So what's this probability? Well, this probability equals to 1 minus 0.1093. Which comes out to be 0.7. Everybody comfortable how I got there? I know this is easy. It's going to get a little bit more interesting very soon. Promise. Scouts Online. Okay. All right, let's try one more and we can move on to other things. Let's look for let's look at between -2 and 1.5 degrees Celsius. So step 1 is what? Well, so let's find the z-scores. Because the mean is 0 and standard deviation is 1, right? The first z-score is going to be -2, and the second z-score is going to be 1.5. right? Negative 2 minus 0 divided by 1 is negative 2. This is, again, a very unique example and somewhat misleading on the difficulty of those questions. So now we have the z-scores. What's next? Yes, thank you. A little more excitement though. It's like a picture! Must has the pictures.
Do you draw two separate or?
Now I'm drawing one. Because I'm looking for something between those two. So, say negative 2 here, 1.5 here. Again, I'm not looking for probability at negative 2 and at 1.5. I'm looking for the area in between. So if I'm looking for the area in between, I'm looking for this space. So how do I get it? If I look at the probability assigned to z-score negative 2, to the left of negative 2, I'm going to get this probability. If on the other hand I look at the probability at 1.5, I'm going to get this probability. So how do I get the middle part?
Except for 1.5 and measure 2.2.
You cannot measure. This table gives you to negative infinity. Negative infinity to your z-score. Sorry? Yes, subtraction. So I get the probability for 1.5. So I get the probability of the z-score equal to 1.5 minus probability for a z-score at negative 2. This minus this gives me this piece. Right? How would you measure which one of us is taller and by how much? You put us next to each other and say, hey, you're a head taller. A head taller. Okay. So, how much is it? Negative 2.
It's 0.0228.
Mm-hmm. So this area right here is 0.0228. How about the probability for 1.56? Sorry, 1.5.
0.9332.
0.9. So this one is 0.9332. So what's our probability? So this area right here,
0.9104.
and that's your answer. Right, the probability of selecting a thermometer which reads between negative 2 and 1.5 degrees Celsius is 91.04%. So far so good? Everybody with me somehow, maybe? Okay. All right, let's keep on going. Right. But this method that we're covering right now allows us to take a value in a population and tell me how unique things are smaller, greater, or in between some certain values. But we need a value to get the probability. It would be neat if we could get a probability and find the value corresponding to it. Right? We very often hear things like 65% of politicians think, right, one or the other. If they're thinking one or the other, we can do binomial. What happens if we hear 65% of the millionaires make at least a certain amount of money? Wouldn't it be nice if we knew how much money they made, right? If we could actually put a number, a gate number to that probability. So what we are going to look at is finding z-score from area. So we're going to find a z-score from area, we're going to work backwards. By using area, and when I say area, I mean probability. Because we are using standard normal distribution, area and probability are interchangeable. To find,
What's the first two words?
work backwards. Is my handwriting really that bad?
If I listen to you while you're writing, no, it's not that bad.
Okay. So listen to the sound of my voice. You're getting very, very sleepy. All right, to find the distance from the mean. And by distance from the mean, of course, I mean the z-score. Right, because the z-score defines what? The distance a piece of value is away from the mean in counts of standard deviations. How many standard deviations is away from the mean? Okay. Well, again, steps. We're going to have some steps. Step one will be draw the picture. Step two, I'm going to use the table. A question got posed my last class. Can we do those calculations in Excel? Somebody has a project at work that they need statistics for. Yes, you can use Excel for this. And if you want to learn how to do Excel, just let me know and I'll put something together to teach you how to do this in Excel. Because you can do this in Excel. You don't have to do it by hand every single time. You just need a formula plugged the right way, which is not very difficult, but again, if you're looking at the Excel's formula for the first time, that is a learning curve. Okay, so let's look at the same company that we had before. In this company, you had this very amazing feature where the mean was 0 and the standard deviation was 1. Very unusual, but we take it. And let's say find the z-score that represents the bottom 95% of the data. Yeah. So find the z-score that represents the bottom 95% of the data. You probably saw the campaigns, the other 99% or the other 95% when it comes to income. Well, this is one of those. Question is, what's the z-score for that? Well, first step is we're going to draw the picture. By the way, I'm not worried how good your picture is, as long as it has the general shape and the markings in the right places. I don't care if it's very steep or very broad, whatever is comfortable for you. It's important that you're consistent with yourself. So what's 95% of the data? Where is the 95% of the data? This way. No. Bottom 95. So we start from scratch, negative infinity, and we take the whole thing. This whole thing is 0.95. Okay, and now we work backwards. So we take our table and we look for 0.95 in the midi part of it. Not the edges, but the midi part.
1.5.
No. 0.95, not 0.9554. 0.95. I'm going to tell you right now, it doesn't exist on this table. But we have two numbers that are very, very close. I'm assuming most of you found those two numbers. 0.9495 and 0.9505. They're corresponding to 1.64 and 1.65 z-scores. So that's the probability, that's the z-score. Yes? You found those two? Okay. Because 95% is something that we use very, very commonly in our life, we will use a more precise z-score than either one of those. We're going to pick a z-score right here in the middle, and I invite you to put a dot on your table or something in the middle, and we're going to use the z-score 1.645. There's three z-scores that are very important to us. One of them corresponds to bottom 95% of the data, and that's 1.645. So just on your table, put a dot in between, and you're going to be good. In all the other cases, you're going to pick the one that is closer between those two. Found it?
Oh, yeah, I found it.
Good. You found the point which I'm talking about? So we're looking 90. Right, so we were looking for 95% of the data. And if you look at closely, it's somewhere here, between those two. Those are the 2 points I'm talking about. So what I invite you to do is I would put a dot, I will put a dot right here, because for this one specific point, which is 95%, we're going to be using 1.645. Because it's very common, we're going to be very precise. Eduardo, are you with me? Excellent. Okay. So we have the z-score corresponding to this probability. In our case, because the factory is so unique, we can talk about the temperature, that 95% of the thermometers read 1.645 degrees or below. Okay. I see you guys are not impressed. Okay, let's do more. No? No? Did I say that at the beginning of the class, bidding will continue to morale improves? So we're going to be doing more problems till you want more problems, and then we're going to stop doing problems. All right. So let's look at a couple things, like top 30%. I just want the picture of this. Bottom 10% and top 80%. Let's look at the pictures, just the pictures. No calculations, no nothing. What would the picture for this look like? Yes, just the picture. You know, draw the goddamn picture part. So just the picture for this.
So it would be shaped, everything should be right.
Everything,
Right, shaded.
where the line? Here?
No. Yeah,
Sure? Okay.
The top 30?
That's the top 30. I call it top 30, it is top 30. It is, right? If you on your in your notebook or any piece of paper you put the 30 here or 30 here,
So,
it doesn't matter. As long as you mark it what it is. Right? Because again, what we are doing in our notebooks on the exams is a representation of it. We are not sitting there actually calculating. Because the 30 will be surprisingly close to here. Okay, bottom 10%. Somebody maybe from this corner. It's been very quiet. What's bottom 10% look like?
Maybe like the very end of
Left, right? Okay. Like that? Cool. Top 80%. I'm looking here. There's some people being very quiet here. Tropical gangster. Sorry? Okay, so I'm going to start with this and then you tell me where to stop. Okay. We're going to play charades. Okay. Where do I put the line? Let's go first. Here? Somewhere here? Or here? Or here? Where do I draw the line? It's not a trick question.
keep going, right there.
Right there? Right here? Okay, and what do I mark? Okay. And this is that. If you don't know what top 80% means, what's the complement of top 80%? Bottom 20. So again, z-score by itself is just a line. It's a border between one and the other, right? The regions we want, the region that we don't want. So it's perfectly fine to look at this and say, hey, where would be the line be for the bottom 20? And that's easy to do. All right, so this was easy. Okay, more. Find the z-scores for the area given maybe for the area, let's go this way, for the area between the bottom 2.5% and top 2.5%. Find the z-scores for the area between bottom 2.5% and top 2.5%. You're talking to me area, probability, z-scores.
Oh, probability.
Yeah, what am I asking for?
Oh, the z-score.
I'm sorry to diminish your enthusiasm. I'm very much appreciated, although a little bit misled.
For the thermometer, right?
No, this is just for anything. I'm asking for the z-scores. Z-scores are independent of what the mean and standard deviations are. If I'm asking for a z-score. So step one is draw the picture. By the way, guys, don't try to skip the pictures. Draw the pictures. You're going to have to draw them anyways. So, draw the pictures. Or, you know, as the Borg used to say, resistance is futile. Star Trek. You guys are way too young. Way too young. So where's the top and the bottom 2.5%? And I'm looking for this. So you're right. This is the middle part is 95%. I'm asking for z-scores. I'm going to mark them. I'm asking for this z-score and this z-score. What do those z-scores mean? Well, sorry?
You have to formulate like the area. We know the area is 0.95.
Oh, let's start with this one. Right, the table gives us the probability for a z-score to the left of the z-score. So if we are talking about this, we are talking about this area right here. Yes? This z-score gives us this probability. So what is this probability? This probability is 0.025. Yes? So what's the z-score? No, that's the probability. Probability talks about area. Z-score talks where the boundary is. So if we look at our table, right? And we are looking for 0.025 right here in the middle of this, in the meaty part. Right? We are looking for this little section. So the picture should help you. You're not impressed with my pictures. That's okay. I had a long day too. It's okay. I'm up since 5. I'm there with you. All right, so let's find the 0.025. Where is 0.025? And I'll tell you we're going to find it exactly. No, 1.96, right? Because the 0 is already in play. So this z-score is negative 1.96. Right? I told you that there are 3 z-scores we're going to use a lot. That's the second one. And just in case you wonder, it has a 0 extra, so we are not worried about it. So this is negative 0.960. So this is our z-score. There are 2 ways to find the other one. Way number 1 is I can add 0.95 to 0.025, right? And get that this area up to here, this whole area, is 0.975. And I can look up the z-score for that. Which means, again, take a look at the table and look for 0.975. 7, 5.
Same number but positive.
Yes. There's the other way to do it. The other way to do it says, hey, how would you describe this graph? Bell shape, symmetric, which means that if something is 1.96 this way, right, it should be 1.96 this way, right? We are missing 2.5% on one side, 2.5% on the other, which means that those two z-scores are the same distance away from the mean. Yes? Which means that the z-score here should be 1.96 as well. So there are two ways to do it. One is we add those two things up and we have the probability and we find the z-score. Right? The other way is to realize that this and this are symmetric. Which
So if
means
you know two z-scores from that point, you can find a median, right? Median.
because it is a standard normal curve,
It's always set to 0.
right? We would need the population mean and the population standard deviation to talk about specific values. Right. Okay. Let's try a real world example.
For that first problem, we just do that negative 1.96 and
Yes, because I'm asking you for z-scores, which means I'm asking you for this value, or both of those. If you remember homework 1, there I asked you for z-scores, so you already know how to calculate them from values. Now you can get those z-scores and you can tell me probabilities as well. So you have both pieces of information. You're judging me. I can feel it. I don't appreciate it, but I can feel it. There's disturbance in the force when people judge me. Okay, example. A population of men has a mean weight of 172 pounds. And a standard deviation of 29 pounds. Let's say that the weight is normally distributed. So weight is normally distributed. So a population of men has a mean of 172 pounds and a standard deviation of 29 pounds. Weight is normally distributed, and we're going to say find probability that a randomly selected man will have a weight of less than 174 pounds. Find the probability that a randomly selected man will weigh less than 174 pounds. So how do we do it?
Draw a picture.
Good. I'll go with find the z-score, but sure, we can draw the picture first. Right. Picture is done. Now let's find the z-score. The z-score is what? The z-score is the value minus the mean divided by standard deviation, which in our case is what? 174 minus 172 divided by 29, which comes out to be 2 over 29, so 0.07. Now the reason why I'm rounding it to 2 decimal places is because our table provides 2 decimal places for z-scores. So 0.07. Do I highlight the left side of this, or I highlight the right side of this? Why? Because it says right here less than 174. Do we expect this probability to be below or above 50%? Above 50%, right? Because up to here would be 50. Okay? And what are we seeing?
93.1%.
What? We
Subtract that number from 1.
we are not subtracting. No, this is a z-score. When we're talking about 1, we're talking about probability.
Oh, okay.
So we want to go. So we want to go z-score to probability, right? So we need to get this z-score. Look it up on the table. If we look at the probability, 5. That's the probability. How do we do it? Again, I look at the table and I go, what am I looking for? 007. So I'm looking at the first row, 0.00, and then I'm looking for a 7. Right? 007. The very top. Okay. So, (52.79% chance of selecting a man weighing less than 174 pounds. Okay, you guys look like you want more. I feel obliged to do so. Z-scores become second nature once you do 20 problems. An easy way to practice if you don't know how to do it and you don't have a textbook is to Google worksheets for Z-scores, for example, and you can find PDFs with just examples, with answer keys and whatnot. Right, example. IQ is normally distributed. With a mean of 100 and standard deviation of 15. What percentage of people has an IQ score between 85 and 125. So IQ is normally distributed with a mean of 100 and a standard deviation of 15. What percentage of people has an IQ score between 85 and 125?
So you set it up as 100 minus 85 over 15, and then 100 minus 125 over 15. And those are your two z-scores.
Yes. So again, z-score is x minus mu over sigma, which in our case is 85 minus 100 over 15, and 125 minus 100 over 15. And we're looking at for two decimal places. The reason why is because our z-score table has two decimal places. So 85 minus 100 minus 15 divided by 15 minus 1. 25 divided by 15, 1.67. So we calculate the z-scores. So step 2. Well, it's starting to sink in. I like it. Usually it's 2 weeks of me saying goddamn picture before anybody actually pays attention. Zero minus 1, 1.67. And we are looking for which area? Between. You have an answer for me? No snoozing allowed. So we're looking for this area. How do we get this area? This area minus this area, right? Because this z-score will give me this probability. This z-score will give me this probability. I'm looking. So I need those two probabilities. Now that I think of it, z-scores are like arranged marriage. If you stick around long enough, you're gonna fall in love. I have 8 weeks to convince you to love z-scores. I can do it. I'm a good matchmaker. I teach statistics. All right, people that haven't spoken yet. Can anybody give me a probability for a z-score of -1? Silence. Seriously? What's the probability associated with z-score of -1?
It's 0.1587.
0.1587? Good. What's the probability associated with 1.67?
Well, that's a 6. Oh, fuck.
How do you get a 4 out of that 6?
You said 5.
No,
5.
I thought it was 1.57. I don't know.
Okay, well, 5 is not bad. It's a 0.1 difference. All right, what do we have for this? So what's the probability for the area in the middle?
0.793.
0. And you said it's 8,
0.793.
7938. So this is this area. And the answer? 38% of people will score between 85 and 125 points on the IQ score.
On our exam, it has to be in full sentences. I know some require it, some don't.
So my rule of thumb is, for now, if I ask you on a quiz, for example, I would like to get a sentence. You can compress it as much as you want, but I would like a sentence. By the time we get to the final, if you just give me this probability of, you put this and this in one line, I'll be happy with. Because by the time we get to the final, I'm assuming you know what this picture means and how to read it. Unless I tell you explicitly to provide me an answer, I'm fine with a very short cut one. For quizzes, I would like a whole answer just so you get practice. Because again, if you're just looking at this number doesn't mean anything without this, right? So we need those two pieces of information, right? This class is about taking statistics and making it real, or taking real information and making a use for it in a model. Okay, so that was too easy. Let's see if we can get something harder. All right, before we go there, let's look at some key points that we have covered so far. So key points. One is the z-score is a distance. What kind of distance? It's how many standard deviations you are away from the mean. 2, area is probability. Right? We forced standard normal curve, so we can make the area equal to 1, so we can equate it to probability. So area is probability. 3, and this is a note that I noticed on the homework, z-scores can be negative. So we can have -2 z-score. Right? But area can not be negative. And I know cannot spelled separately is bad grammar. It's important that you understand it cannot be negative. Cannot. I'm going to put an apostrophe here. Cannot be negative. Area cannot be negative. Why? Because probability cannot be negative. Because you cannot have area negative. Negative area means the area is somewhere else. You cannot make it disappear. So those are the key points. Now, having those in mind, let's continue. We can find data data values from z-scores. How do we do it? Well, we know that the z-score is equal to x minus mu divided by sigma. Then I can multiply both sides by sigma. If I multiply both sides by sigma, I get z times sigma equals to x minus mu. If I subtract mu from both sides, I get mu minus z-score times sigma equal to x. add mu to both sides, and here is multiplied by sigma both sides. So I get this. X equals mu plus. And again, how do we do this? We draw a picture, we look up the z-score from the probability, and then we calculate the x. Okay, let's look at an example. Man weights. Well, what do we know? Mean was 172, standard deviation was 29. Oh, yes. And then the question is, what weight separates the lightest 99.5% from the heaviest 0.5%. I assume some of you go to the gym and there's like a wall of achievements, people that lost a lot of weight, right? So the question is, what weight separates the heaviest 0.5% of men from the lightest 99.7? Okay. Step one, we don't know how to start. We do what? Draw the picture. Draw the picture. Where's 0.5%? This is 0.995. So this is 0.005. Right? So we are looking somewhere here, maybe. 0.005. Let's go this way. 0.005. This area, and this is 0.995. So what's the z-score? If you want a value, right, the following we need to go. We need to go from probability to a z-score to a x value. That's the step. So now we have the probability. We need to find the z-score. Right. Step 2 is finding the z-score. So how do you find the z-score? We look up this probability, right? Because the probability is to the left of the z-score. So all of this. So what's the z-score? And it's
2.575.
yes. This is the third special z-score. 575. 2.575. This is the third special z-score we're going to use a lot. So if we look up this, we're going to find this. And it's right here. If you want to put a dot between those two, that's fine. It's right here. 2.57 and either 4, 7 or 8. So between those two, try to put a dot there. Okay, that's the third number we're going to use a lot, so just bear with me. Okay, so we have the z-score. So what now? Well, now we're going to use the formula x equals to mu plus z-score times sigma. So x equals to mu 172 plus 2.575 times sigma, which is 29. And that comes out to be 246. So 246.7 pounds is the weight that separates the heaviest 0.5% from the other 99.5%. I know you guys want more, but I think we had enough for today.